All right. Folks, today we are learning about the equation of a line even further than what we've already done so far. And this lesson is the absolute culminating of everything we've done up to this point. Um, you might remember that last week, the lesson before this, we got the equation of a line when we were given the slope and 1 point. Now today, we're going to still find the equation of a line, but we're only given 2 points. That's all we're given. So to start off, I have a little investigation here. And it says, determine the equation of a line. So the moment you hear the equation of a line, you know that they want this y equals mx plus b. So determine the equation of a line that passes through the points 1, 4 and 3, 10. Now, you could pretty much do every single question this way in this investigation, but it might not be the most efficient way. So let's first use the tools that we know. The first thing we're going to have to do is find the slope, m. We're going to find the slope of this line. So we're going to do that by first plotting the coordinates 1, 4. So here's 1, 4, right about there. And we have another coordinate. We got that one. We got another one, 3, 10. So we go 3 and 10, way up there. So we plot these two coordinates, and what we're going to do is we're going to connect the dots with a little line like that. Okay. So as we know, in order to get the slope of this line, we have to calculate the rise, and divide it by the run. So when we have a look at this line over here, we count up for the rise and we count across for the run. So if you start at this point 1, 4 and you start counting up, you see 1, 2, 3, 4, 5, 6. So we've gone 6 up. Now going across for the run, it's just 1, 2. So our rise is 6 and our run is 2. And if you go ahead and put this in your calculator, 6 over 2, or maybe even 6 divided by 2, it's going to give you 3. So the slope of this line must be 3. Now, in order to get the y-intercept, or the b value in our equation, y equals mx plus b, we need to know where this particular line here crosses this y-axis. And in order for us to do that, what we can do is we could extend this line. So using your ruler, you extend it, and you'll notice it crosses the y-axis perfectly at positive 1. So you could say that your b value here is positive 1. So altogether, the equation of this line in y equals mx plus b that goes through the coordinates 1, 4, and 3, 10 is going to be y equals, and we're going to say 3, right? The slope is 3, and we'll put an x beside that. And the y-intercept is positive 1. So the equation of this line is y equals 3x plus 1. Now, to do every single question this way would be a little bit unreasonable. And that's where on this next part here, I'm like, well, what if we couldn't graph the points because they might be unreasonable coordinates? Like maybe they're decimals, or maybe the numbers are just enormous and we can't put them on a graph. So we would certainly need another plan of attack for sure. Now we're going to do the same thing. We're going to get the equation of the line that passes through the same coordinates at 1, 4 and 3, 10, but we're going to do it algebraically. Now, as we know, when we're talking about the equation of the line, we need two very important pieces of information. First, we need the slope, and we also need the y-intercept. Once we have that's basically our value of m for slope and our value of b for the y-intercept. Once we have those two, we can really simply state the equation of the line really quickly. Now, In order to solve for the slope without a graph, we would have to determine the slope of 2 points using this wonderful formula that we have here. And the formula is slope, or m, equals y2 minus y1 over x2 minus x1. Now, if you recall, we did a little bit of this when we learned about slope. See this first coordinate here, 1, 4? We know that the x value is 1 and the y value is 4. And if you look at the coordinate 3, 10, you know that the x value is 3 and the y value is 10. Now, because, this is the coordinate number 1, we'll call this combination of xy x1 and y1. And this is the second coordinate, so we'll call this combination of xy x2 and y2. We'll use this in our slope formula. So m is going to equal y2, which is 10. Take away y1, which is 4. So we'll write it like this. 10 minus 4 divided by x2, which is 3, minus x1, which is 1. So we'll set that up. And the reason why I have brackets around the 10, the 4, the 3, and the 1 is because I've replaced a variable with a number. So really quickly, we'll simplify the top. 10 minus 4 is 6, and the bottom, 3 minus 1 is 2. So again, if you put that in your calculator, your slope is going to equal 3, just like it did on the previous example in the investigation. Slope is equal to 3. We just did it algebraically. I mean, could we put it on a graph, rise 6, run 2, and divide them? Yeah, for sure. But we're doing it algebraically here. Now, with this slope, all of this becomes very similar to the other day, because now you have to determine the equation of a line that we now know has a slope of 3 and crosses 1, 4 and 3, 10. So it's our job now to get the y-intercept. So we're going to start off by stating the equation of our line so far. We have y equals 3x plus b. Now at this point, based on our prior knowledge, we would just take the one coordinate that we were given on the last lesson and just plug it in. But now we have 2 coordinates. We have 1, 4, and we also have 3, 10. So you might be wondering, well, which coordinate do we substitute in for x and y to get the correct answer? And well, the answer to that is it actually does not matter which point that you choose. You're going to arrive at the exact same answer. And the reason why that happens is because both of these points satisfy this line. Like both these points are on this line. So let's just choose one of them. I'll choose the point 3, 10. And if you're really curious, you could choose the point 1 and 4. And you're going to see here how we get the same answer. So I'm going to sub in, 3 for the x value and 10 for the y value. So instead of it saying y equals, we'll say 10 equals 3 and then times 3 plus b. So instead of the x, we got a 3 here. We'll do some we'll do some simplifying here because 3 times 3 is just 9. So we have 10 equals 9 plus b. And in order to solve for that letter b, we're going to have to take away 9 from each side of the equation. And as we know, this ends up being 0. It is completely gone. And 10 minus 9 is just 1. And I'll put a box around that. And again, we're probably not too shocked because we knew that the y-intercept here was going to be positive 1. So altogether, what you're going to do is you're going to take your value of m over here, you're going to take your value of b over here, and you're going to state your equation. So our equation is y equals 3x plus 1. We've just replaced the value of m with 3 and the value of b with 1. And that is it, folks. That I like to coin this particular method of solving for the equation of the line as one of the toughest problems in grade 9 math. It truly, truly, truly can be that way. This is a tough problem. I don't think this is easy at all, but it's important that we nail this down because I can assure you that in the later grades, this is going to become quite important. Okay, let's try another one. Determine the equation of the line in y equals mx plus b that passes through the points -3, 23 and 5, -17. You'll notice that, see, I've chosen two coordinates that are quite unreasonable to graph here. So could you draw the graph and plot -3, 23 and 5, -17, draw the line? You totally could. But a more efficient way might just be to use algebra. So our first step is we're going to solve for the slope. And in order to do that, we're going to use our slope formula between 2 points. And that is m equals y2 minus y1 over x2 minus x1. Now from here, we're going to have to determine, well, which is y1, which is y2, and stuff like that. So we look at the first coordinate here, and we know each coordinate has got an x value and a y value. And because this is the first coordinate, we'll call it x1 and y1. And 5, -17, we notice the x value is 5 and the y value is -17. We'll call this x2 and y2. Now, a common question grade 9 students have is, well, could I call this coordinate x2, y2, and this one x1, y1? And the answer is yes, you really could. I just chose to leave it, like this, where the first coordinate is x1, y1, and the second coordinate is x2, y2, because, well, that was just the first coordinate, so I just called it x1, y1. But if you wanted to call that first coordinate x2, y2, and the second coordinate x1, y1, you totally could. But I just did it for simplicity's sake. So we will replace these values. So instead of y2, we'll put -17. Instead of y1, we'll put 23. But please ensure you're putting these in brackets. See, in the previous example, replacing these with brackets, well, you're probably thinking, well, I don't really need to. But in this particular example, you'll see the importance of that. See, on the numerator, we have -17 take away 23. Okay, cool. But in the denominator, we have 5 subtract -3. And it's really important that that -3 is in brackets, because you'll notice, some of you might know the trick where you see this double negative happening and you know it's got to turn to a positive. And if you didn't have the brackets around the -3, it might not be that obvious. So when we simplify the top and bottom, we should get -40 divided by 8. And in your calculator, you go -40 divided by 8, and you solve for the slope of -5. Is that -5? -40 divided by 8? Yeah, -5. And we'll put a box around that, because we know that is one crucial piece to our y equals mx plus b. It is the m part. That's m. Maybe I'll put an m here. Now, using this, we're going to get our y-intercept, which is the b part of y equals mx plus b. And we'll do that by first stating our equation of the line so far. Our equation is y equals -5x plus b. Now, in order to solve for b, it has to be the only variable in the whole equation. So we got to fill something in for x and put something in for y. And again, you could choose either one of the coordinates. You can either choose -3, 23, or you could choose 5, -17. Let's see what I chose. Oh, I chose -3, 23. So sub those in for x, -3 in for x, and positive 23 in for y. And off we go. We'll replace these values. So instead of y equals, it's 23 equals -5 times -3. That's why we put brackets around that, plus b. We'll simplify the -5 times -3, and that ends up being positive 15. So we have 23 equals positive 15 plus b. And again, to solve this equation, we're going to take away 15 from each side. And what we're left with is 8 equals b. And we'll put a box around that. So in our equation of y equals mx plus b, we're going to state our equation and say y equals, well, that should be negative 5x plus 8. And that's the equation of a line that passes through the points negative 323 and 5, negative 17. Not bad. Folks, it is a lot of steps. In fact, when you're working on some of this homework, it might be a good idea to have example 1 or 2 out in front of you just so you can see these steps and kind of how they're laid out. Okay, now what I've done in this last example is I've included a word problem. And this is actually a true word problem. The numbers here, the values here are all true. It says here, Mr. Yakimishin has recently joined Good Life Fitness. He pays a monthly fee, right, and a startup fee, which is true. When I signed up at Good Life, they had me pay like an initial fee or like a starting fee, and then they charged me a certain amount each month. So I've given you just some data here about what happened. So after 5 months, I paid a total of $300. And after 12 months, I paid a total of $580. This is true. Now it says here, what is the monthly fee and what is the startup fee? So when you see monthly fee, maybe you can think of that as monthly rate or slope. And when you see the startup fee, you could think of that as like the initial cost or perhaps the y-intercept. Now, before we actually dive into this, I want to tell you some common misconceptions here. I see a lot of students in the past saw this information right here, and what they really did quickly was they did 300 divided by 5 is 60. So they right away thought that I was paying $60 per month. And then they thought, well, maybe it should be the same here, because 580 divided by 12 should also give me the same number. But if you did 580 divided by 12 in your calculator, it gives you 48.333333. So you're getting different answers here, which might set off a little alarm in your brain to say, hey, something's wrong with that. And that's true. Something is wrong with that. That's not the way in which we're going to calculate the monthly rate. Instead, what we're going to do is we're going to identify the independent and the dependent variables. So as you might remember from Unit 3 and a little bit of this unit, the independent variable is usually time. And in this case, we have months. So we have time in months. So our independent variable, x, is time in months. And our dependent variable is the total cost. Yeah? So from this information, you might be able to just see it. You see an ordered pair of 5 and 300. And you see another ordered pair as 12, 580. So these come together to be coordinates. So at 5 months, he paid $300, and that's where you're getting the coordinate 5, 300. And at 12 months, he paid 580, and that's where you're getting the coordinate 12, 580. And what we're going to do with these coordinates is pretty much treat them now as if they're coordinates on a graph. And we're going to do almost exactly what we did before. In order to solve for the monthly rate or perhaps the slope, we're going to have to calculate the slope between two coordinates. We're going to use the formula m equals y2 minus y1 divided by x2 minus x1. Now, we're going to label this first coordinate as x1, y1. And we'll label the second coordinate as x2, y2. Now from here, we're going to replace these values in the formula. We're now going to have m equals 580 take away 300 divided by 12 minus 5. So in your calculator, I'd like you to simplify the top and then simplify the bottom of this. So 580 take away 300 is 280, and 12 take away 5 is 7. Let me double check that. 580 divided by 300 is 280. 12 minus 5 is 7. And then we'll divide this. So 280 divided by 7 equals 40. So the monthly fee that I pay is $40 a month. That is the rate of change. So you could even say $40 per month. Now, in order to get the startup fee or the initial cost, or perhaps the starting value or initial value, we're going to first look at this equation as what it is so far. It is first y equals 40x plus b. Now, in order to solve for b, this initial cost or y-intercept, we're going to have to sub in a coordinate. And again, it doesn't actually matter which one you choose. Which one did I choose? I chose to sub in the point 5, 300. And the reason why I've been choosing this coordinate, I always choose the one that has the smaller values, like 5 and 300 versus 12 and 580. It's just smaller numbers to work with. So what we're going to do is replace the independent variable x with 5 and the dependent variable y with 300, just like that. So we have 300 equals 40 times 5 plus b. And what we're going to do is quickly do 40 times 5 in the calculator, and we get 200. 40 times 5 is 200. That's right. In order to solve for b, we're going to subtract 200 from each side here, and we get 100 equals b. So we now know the monthly rate is $40 per month. We also know that the initial cost, or perhaps I called it a startup fee, the startup fee is $100. So if we wanted to answer this question, we would say, therefore, the monthly fee is $40 per month and the startup fee is $100. Okay. Boys and girls, I want to remind you that I'm well aware this is some of the toughest algebra that we do in grade 9 math. It truly is. So if some of these problems are difficult, I'm going to be here to help you out as much as I possibly can, but I don't want you to give up on them. As you're working away on some of this homework, I highly, highly encourage you to have this open right in front of you as you're approaching these problems. I'd like you to have this first, solve for the slope, the formula, I want you to have this right in front of you as you're tackling these homework problems. And I can assure you, yeah, of course, there's going to be some word problems in the homework. I'd like you to think about the independent variable and the dependent variable. Okay, folks, that is all. If you do have any questions, please feel free to let me know at any time. I am happy to help. Enjoy.